Howdy, geometry students. This video looks a little bit different, doesn't it? You don't see me or my face at all, and quite honestly, that's probably a good thing. It's after 9 o'clock. I'm a little bit tired with all of this e-learning stuff. My kids have to have access to well, not both of them. The one in second grade has to have access to Wi-Fi all the time to be able to do her work. And y'all know the school is not conducive to good Wi-Fi, so it's making it a little bit difficult for me to get up there and do a video. And so I'm gonna do one this way, and I think it's gonna work. One thing I want to say as we are entering into the next couple of sections, we are going to be doing trigonometry, which I love. Let me encourage you, especially those of you that, you know, math is not your favorite thing and sometimes it's kind of hard. Usually, and I've been teaching geometry for over a decade, usually this particular information, this quiz, this test, whatever, is one of the highest grades of the year by most students. They just seem to be able to follow it really well. They find it easy. They find it enjoyable even. So I'm crossing my fingers that you do too. I will say that you need the use of a scientific calculator. Now, I really like these. It's what we use in the classroom occasionally. We haven't used them a whole lot this year. You can use any scientific calculator, and I'll try to remember to put a link for, you know, an online one that's free in RenWeb. But you can just go to Google and type in free scientific calculator, and I'm sure you'll find stuff that pops up. But if you have your own, you know, use it. You can also use if you have an iPhone, I don't know about Androids. I know iPhones, if you turn them to the side, and I would show you, except I'm using mine to make this video, so I can't. If you turn it to the side, the only thing I don't like about the iPhone is the way you have to type it into the calculator is different than like a regular scientific calculator. It's not as user-friendly, so I would say use that at last resort. But we're gonna jump in to section 9.5. We're going to be using trigonometry with right triangles. So what we're doing specifically deals with right triangles. We can't, at the moment, we can't use this with obtuse triangles or acute triangles, just with right triangles. So let's get started. And it says that the word trigonometry comes from two Greek terms, trigon, meaning triangle, and metron, meaning measure. So trigonometry is all about finding measurements of triangles. I'm currently teaching trigonometry also in pre-calculus, but it's much more in-depth there. So you're kind of getting just a taste of it. There's so much more to trigonometry than what you're going to get in geometry, but you'll get a pretty good taste of it. So we have what are called trigonometric ratios. That's a fun word, isn't it? Trigonometric ratios. It says a ratio of the length of sides of a right triangle is called a trigonometric ratio. Now, I'm typically just going to say trig ratios because you try saying trigonometry or trigonometric 20 times in 10 minutes and you get tired of it real quickly. The three that we're going to be using that are the most common are sine, cosine, and tangent, and they have abbreviations. So this isn't sin. This is sine, it's just the abbreviation for it. This isn't cos, it's cosine, it's the abbreviation for it. And this isn't, I mean, it looks like tan, but every time I say it, I'm gonna be saying tangent. So those are the abbreviations for sine, cosine, and tangent. So here you have the names, the actual names, sine, cosine, tangent. You have the abbreviation, so that would mean sine of angle A, cosine of angle A, tangent of angle A. And then we're gonna talk about what they mean. So the definition for sine of angle A is opposite over hypotenuse. Opposite over hypotenuse. The definition for cosine is adjacent, and that's a word we've used a lot this year, right? Adjacent over hypotenuse. And then tangent of angle A is going to be opposite over adjacent. Opposite over adjacent. So what all math teachers say is SOHCAHTOA. Let me see it right. Oh, sorry. I'm sorry if this video shakes, y'all. Every time I put my hand on the table, it shakes. SOHCAHTOA. SOHCAHTOA is just a mnemonic device to help you remember these definitions right here. So the SO part just means that sine is opposite over hypotenuse. So the S, the O, the H. The CA is letting you know that cosine is adjacent over hypotenuse. So the C, A, H. And then TOA is reminding you that tangent is opposite over adjacent. So T, O, A. Now I did used to work with a math teacher, and I don't know if he came up with this or not. I hope he didn't come up with this, but anyway, something that helped some of his students. And before I say this out loud, let me preface this by saying, no, I don't condone the use of drugs. This is just what helped some students remember it. If they couldn't remember SOHCAHTOA, they could remember some old hippie caught another hippie tripping on acid. Now that's going to be the only time you hear me refer to that. If you think that that will help you remember it, then remember that in your head, but I'm going to continue to say SOHCAHTOA. Okay, so let's use some SOHCAHTOA, and real quick I'm just going to write it at the top of my paper to give me a visual. So I am a visual person. All right, so example number 1 says to find sine of S, cosine of S, tangent of S, sine of E, cosine of E, and tangent of E. So this is just going back to testing whether or not I know my trigonometric ratios and their definitions. So I'm going to start with sine of S. Now here's what that means. I am looking at angle S, and I need to determine what is the opposite side and what is the hypotenuse. Now we've talked a lot this year about that word hypotenuse. We said hypotenuse is always the longest side, but most importantly, it's always the side that's across from the 90-degree angle. There's only one hypotenuse in a triangle, so once you figured it out, that's it. Opposite, though, is going to depend on which angle you're looking at. If I am currently looking at angle S, then the side that's directly across or opposite or not touching S at all is that side right there that has a measurement of 3. So when I go to do sine of S, I'm going to do 3 for opposite because it's directly across, opposite, not touching angle S. And then I'm going to do 5 as my hypotenuse because it's across from the 90-degree angle and it is the longest side in the triangle. And that's it. 3/5 is reduced. It's done. All right, we are still looking at angle S. But this time we want cosine. So remember the CAH, C-A-H. That means I want adjacent and hypotenuse. Well, we've already determined that the hypotenuse is 5, so that is not going to change. Adjacent means which leg is touching angle S. Well, if the 3 is the opposite and not touching angle S, that leaves us with the 4. It's the other leg, and it's touching or helping to form angle S. So 4/5 is my answer for cosine of S. All right, so tangent of angle S. This is the TOA, opposite over adjacent. Well, we already identified 3 as the opposite. We just identified 4 as the adjacent, and we're done. So now we're going to turn our attention to angle E, which means some of this is going to change. I'm not going to look at angle S any longer. Now remember I told you once you find the hypotenuse, it is what it is. So that 5 is not going to change from being the hypotenuse. What does change is your opposite and your adjacent, because now if I'm looking at angle E, across from it, directly opposite from it, is the 4. So I'm going to have 4 over 5. 4 is the opposite of angle E, 5 is the hypotenuse. Now I'm going to go to cosine of E. This is where I want adjacent over hypotenuse. Well, remember the hypotenuse is not going to change, and adjacent is going to be the leg that's touching angle E, which is the 3. And then lastly, we're going to do tangent of angle E. Again, that's going to be opposite over adjacent, TOA, and I'm going to have 4 over 3. And that's all there is to finding your sine, cosine, and tangent when you are looking at an angle. So I'm going to encourage you, pause the video, try example 2, reduce fractions if necessary, and then pick back up and let's see where we're at. Pause, pause. Okay, I'm going to get going. So sine of A, so I want opposite over hypotenuse. I'm looking at angle A. Opposite of that is 10, and hypotenuse is 26 because it's across from the 90-degree angle. Both of those numbers are divisible by 2, and so I'm going to get 5 over 13. All right, cosine of A. So this time I want adjacent over hypotenuse. 24 is adjacent. 26 is still the hypotenuse. Both of those numbers are divisible by 2, and so now I have 12 over 13. Tangent of A, I want opposite over adjacent. So I'm going to have 10 over 24. Again, they're divisible by 2, so I get 5 over 12. So hopefully you guys did good with angle A. Now let's go to angle B. So this time, this is the angle I'm looking at. So sine, I want opposite over hypotenuse. So across from angle B is the 24. Hypotenuse isn't changing. We're going to reduce and get 12 over 13. Cosine of B, so I want adjacent over hypotenuse. That gives me 10 over 26, and that reduces to 5 over 13. And last one, tangent of B. This is where I want opposite over adjacent, so I'm going to do 24 over 10, and that reduces to 12 over 5. So hopefully you feel like SOHCAHTOA is pretty easy. You just have to be able to identify those 3 sides: opposite, adjacent, and hypotenuse. Okay, so now let's get into how do we use the calculator, because I know students love to use calculators. So it says before using the trig functions on the calculators, you first have to make sure that the calculator mode is set in degrees. Now it depends on what kind of calculator you have. So let's say you're using this one right here. I'm turning it on. If you go right up here to mode and push that button, at the top you see DEG, RAD, and GRAD. Those are your 3 measurements for angles: degrees, radians, and this one you might not ever learn about at all. We use radians a lot in pre-cal. We also use degrees, but in this class this year we're only going to use degrees. So you need to make sure that it says degrees. Mine does because it's blinking on that. Now if yours, let's say yours looked like that, where the RAD was highlighted, you would just move your cursor to where you want it to be, hit enter, and it will no longer highlight radians. Now if you have a graphing calculator like mine, all right, same idea. Turn it on, go to mode, lots more choices here. Right here, radian, degree. Mine's already highlighted to degree, and that's what I want. All right, so I'm gonna go back to using the other calculator. So example 3 says find each value using a calculator, and we're gonna round to the nearest 10 thousandths. So let's talk about where are the 10 thousandths placed. Well, if you have a decimal point, that first digit is the tenths place. Then we have the hundredths place, then the thousandths place, then we have the 10 thousandths. So 10 thousandths, that means we want 4 digits after the decimal point. Well, you're gonna have to look at the 5th digit to determine how you're gonna round it. So remember, if it's a 0 through 4, you're gonna keep it the same. If it's a 5 or higher, you're gonna round it up. So we want, first of all, cosine of 41 degrees. Well, here you can see my trig buttons, sine, cosine, tangent. So I'm gonna hit cosine, parentheses pops up. I'm gonna hit 41. I'm gonna close my parentheses, and I'm gonna hit enter, and I get a lot of digits. So remember we said we were gonna have to look at the fifth one to determine what we do to the fourth one. Well, since it's 0, this 7 is gonna stay the same. So I'm gonna say that cosine of 41 degrees, I'm gonna use an approximate symbol because we're rounding. It didn't come out exact, so approximately 0.7547. Do you need to use that approximate symbol? Yes. In this section and the next section, as we're using the calculator and we're inevitably going to be rounding a lot, you need to use that approximate sign since we're not getting exact answers. All right, so hopefully you have a calculator. Let's try sine of 78 degrees. Again, you're just punching in the sine button, you're typing 78, hitting enter, and mine has told me that is approximately 0.9781. All right, let's do cosine of 84. Again, you're just punching it in. We're going to use the approximate symbol, and I am getting 0.1045. And last one, we're going to do sine of 43 degrees, and I'm getting 0.68. Now look at these next two digits, 199. Well, the 9, this 9 tells me, this 9 tells me that this has to go up. Well, what happens if this goes up? That goes up too. So the 19 then turns into a 20, so 0.6820. Okay, now let's get into actually using these trig functions. What do we use them for? Let me show you. So example 4, our goal is to find the missing side. Now the way that we have, Coco! Sorry, my dog won't stop scratching the couch and it's driving me nuts. So the way that we have done these types of problems in the past is we've used the Pythagorean theorem. The problem with that is you need to have two sides to find the third side, and we don't have two sides, we only have one side. So we have an angle measure, we have one side, and we have the missing side that we're trying to find. So if I'm looking at this angle, and I'm always basing it off of one of those acute angles, not the 90-degree angle, but one of those acute angles. If I'm looking at that 42 degrees, I'm going to ask myself, what words would I use to describe the x and the 12? And the words that I'm talking about are opposite, adjacent, and hypotenuse. So you might for a minute need to write SOHCAHTOA on your paper as a visual. So 42 degrees. Directly across from it is the x. So the x is going to be the opposite side. The 12 is across from the 90-degree angle. That makes it the hypotenuse. So we have opposite and hypotenuse, which is going to tell me that we are going to use the sine function for this problem. We're not going to use cosine, we're not going to use tangent because we didn't have the adjacent side, but we do have opposite and hypotenuse. So we're going to do sine of that angle measure of 42 degrees, and we're going to set it equal to opposite over hypotenuse. So hopefully you kind of followed along with where that came from. Remember, we chose the sine function because of the words that we used. We had opposite and hypotenuse. So sine of 42 degrees equals x over 12. Now I always tell students, you're not allowed to use the calculator until on your paper you get x by itself. So let's talk about what we would do. Right now there's division happening between the x and the 12. So I'm going to do the opposite, which is multiplication. I'm going to multiply both sides by 12. So I have 12 times the sine of 42 degrees equals x. And once I have x by itself, now's when I get to use my calculator. And you can type it in just like you see it. So I'm going to type in 12 times sine of 42 degrees. Important to note, you actually don't have to type in the multiplication sign. If you were to just type in 12 sine of 42, the calculator knows to multiply those. So if you don't press that multiplication sign, no big deal. Hit enter. And we are going to round, let's round to the nearest tenths place. That's one digit, so we have to look right there to see what's going to happen. The 2 is going to tell us to keep the 0 the same. So we're going to say that x is approximately, because remember we're rounding, 8.0. And that's going to be our answer for example 4. All right, example 5. Again, I'm going back to SOHCAHTOA. All right, so I'm gonna look at this 76-degree angle. The X is across from the 90-degree angle, and that lets me know that that is the hypotenuse. The 19 is one of the legs, but it's not across from the 76-degree angle, it's actually touching it. That makes it adjacent. So look at what we have. We have adjacent and hypotenuse, which means we're gonna use cosine, not tangent and not sine, because we don't have opposite. So we have cosine of our angle measure of 76 degrees equals adjacent over hypotenuse. Okay, remember, you're not allowed to use the calculator until you get X by itself, and we have a little bit of work to do. So look at where the X is. It's not in the numerator, it's in the denominator. Why is it in the denominator? Because this fraction bar means division. How do you undo division? You multiply. So the first thing I'm gonna do is multiply both sides by X. So I have X times cosine of 76 degrees equals 19. Now remember, we have to get X by itself before we can use a calculator. The X is joined to the cosine of 76 degrees by multiplication. So to undo that, we're gonna divide it on both sides. So I'm gonna divide each side by cosine of 76 degrees. And I now have X by itself. So I'm gonna come over here and plug it in. Now I've got mine in math print, right here. You don't have to have it in math print, but the thing I love about math print is when I hit this button right here that has N over D, which stands for numerator over denominator, it pulls it up and looks like a fraction, and I really like the way that looks because it looks just like it does on my paper. So I'm gonna do 19 divided by cosine of 76. No big deal if yours isn't in math print, you would just do 19 divided by cosine of 76, and it would look different here, but it would come up to the same answer. Remember, we're gonna do to the nearest tenths place, so we're gonna say that X is approximately 78.5. All right, example 6, here we go. Let me real quick write SOHCAHTOA. All right, we're looking at a 13-degree angle. The 9 is opposite from it. The X is touching it, but importantly to note, it is not the hypotenuse because X is not across from the 90-degree angle. So that means we have adjacent. So we're gonna use TOA because we have opposite and adjacent. So I'm writing tangent of 13 degrees equals 9 over X. And we see a similar problem to what we just did. We need to start by multiplying both sides by X because we saw division. So I have X times tangent of 13 degrees equals 9. And then the X is joined to the tangent of 13 degrees by multiplication. So to get rid of it, we're gonna have to divide each side. And that allows us to get X by itself. And so then I need the calculator. So again, I like the math print. If you can get it, it's pretty nice. So we have 9 divided by tangent of 13 degrees. And I'm gonna hit enter. And look at the tenths place. What's it gonna do to the 9? It's gonna round it up, which is in turn gonna round that up. So we're gonna get approximately 39.0. And there we go for our missing side. All right, so hopefully SOHCAHTOA is seeming pretty easy. We're gonna now apply it to word problems. Don't freak out, word problem just means draw a picture. So let's look at example 7. It says a plane is 1 mile above sea level when it begins to climb at a constant angle of 2 degrees for the next 70 ground miles. How far above sea level is the plane after the climb? Okay, so first of all, we have this plane. Now y'all don't laugh at my drawings because you know they're always pretty terrible, but there's my plane. It's the best I could do. And it tells us that it is 1 mile above sea level. That just means how high is it in the sky. So I'm gonna just put this line right there. That is 1 mile high. Okay, well actually, It's not terrible, but let me just put it there instead. Okay, so we know that right now it has a height of 1 mile above the ground. Here's what it says. It says it begins to climb at a constant angle of 2 degrees. So obviously the plane is still going to fly this way. I'm drawing a dotted line to show you that it's still going to continue to fly going in that direction. But what's going to happen is not only is it going in that direction, but it's tilting up just slightly by a 2 degree measurement. So it's still continuing to fly forward, but as it does, it's going to climb a little bit as well. I hope that makes sense. And it says that it's going to do that for the next 70 ground miles. So in other words, from here to here, let's say, is 70 miles. Now the question says, how far above sea level, in other words, how high is this plane after its climb? So let's say its climb ends right here at that 70 ground miles. How high is it above the ground? That's what we want to find. Now what I want to encourage you to do is look at the picture that we've got, and obviously we will want to focus on finding a right triangle, which if you could see the right triangle, and I wish I had access to a highlighter. Let's see if I can find one real quick. I mean, I feel like you can probably see it, but just in case. That would be the right triangle that we're looking at. So here's the good news. We have this angle measurement right here of 2 degrees. We know that this bottom line right here is 70 miles because the dotted line that I drew is parallel to the ground. So those are going to be that same distance there from start to finish. And so before we can find the answer to the question, which is how high is the plane from the ground, what I'm going to do is first put an X right here because I first need to find this measurement right there where my pencil has kind of darkened that in. So I'm looking at the 2 degrees. And I'm going to ask myself, what words can I use to describe the X and the 70? Well, neither of them are the hypotenuse because the hypotenuse is across from the 90-degree angle. X is across from the 2-degree angle, so it's opposite. The 70 is touching the 2-degree angle, and it's a leg, so it's adjacent. So which trig function uses those 2 words? You may have guessed it. That's going to be tangent. So tangent of 2 degrees is equal to opposite, which is X, over adjacent, which is 70. Well, how do I get X by itself? Easy. I'm going to multiply both sides by 70. And now that I have X by itself, I'm going to let my fingers do the work with the calculator. So I'm going to do 70 times tangent of 2 degrees. Hopefully you are doing this at home as well. 70 times tangent of 2 degrees. And so I'm going to get approximately 2.4. So X is approximately 2.4. All right, so here's a lot of times where students like to end, but have we answered the question? No, because the 2.4 only represents this part right here. And the question is, how far above sea level, how far above the ground is the plane? So not only is it this measurement, but do you guys remember what this part is? Well, remember that was the 1 mile. So we're going to take our 2.4, add it to the 1 mile that was already there, and that's going to give us a grand total of 3.4 miles. So that particular plane is 3.4 miles above the ground. That was a pretty easy one, right? Okay, last example. It says a 16-foot ladder is propped against a building, and the angle it forms with the ground measures 55 degrees. How far up the side of the building does the ladder reach? Okay, so we have this building right here. There's my door. All right, we have a ladder leaning against the building. Obviously, the ladder is touching the ground, right? Hopefully my picture is making sense. So here's what they told us. They told us that the ladder is 16 feet. Well, what is that going to be? It's going to be right here. Okay, I'm hoping that the builders, the construction workers, the architect built this building so that it's perpendicular to the ground. So I'm going to assume that there's a right angle there. If not, this building is not up to code. We are going to assume that it is. So it says the angle the ladder, forms with the ground. So you have two options, this angle and this angle. This angle is the ladder and the building. This angle is the ladder and the ground. So right here is where we're going to put that 55 degrees. Then it says, how far up the side of the building does the ladder reach? I'm going to put an X right here. I want to know how far up the side of the building. Okay, so if I'm looking at this 55-degree angle, what do you guys think? What do you think X is going to represent? Is it going to represent hypotenuse, adjacent, or opposite? It's going to represent opposite. What do you think about the 16-foot ladder? Well, it's across from the 90-degree angle, so it's going to represent the hypotenuse. Which trig function uses those words? Hopefully you're guessing sine. So we have sine of 55 degrees is equal to opposite, which is x, over hypotenuse, which is 16. We need to get x by itself. We're going to multiply both sides by 16. And then we're going to use our calculators and do 16 times the sine of 55 degrees. And again, we're going to round it to the nearest tenths place, and we're going to find out that it's approximately 13.1, but it's a word problem, so I need units. What unit of measurement should we use? Well, let's go back to the ladder. It was in feet, so we're going to use feet as well. So that ladder was leaning against the wall, the side of the building, up 13.1 feet. All right, hopefully you saw that this is not terribly difficult. You just need to learn SOHCAHTOA. Once you can remember that phrase, you've got it. The calculator helps us out a lot, and I will talk to you guys in the next video. Bye.